Okay, for the second part of 4.6, we just have a couple practice problems. So we're going to start with example 4. We want to find a polynomial function with real coefficients of lowest possible degree, having a 0 of 2 with a multiplicity 3, a 0 of 0 with a multiplicity 2, and a 0 of I with a single multiplicity. So what we're looking at here is you've got an x equals 2 3 times. You have an x equals 0 2 times. And then you have an I with a single multiplicity, but these come in pairs, so you have a negative I. So if I set this up as x minus and then my zeros, I'm going to look like this. X minus 2 3 times. Okay, x just by itself, minus 0. And then x minus I, x minus negative I, which gives us x plus I. Now, I could multiply all this out, but I'm not going to make you guys do that. So for this one, all I need you to do is just go like this. X minus 2 cubed. And then x and x, you can put that one in the front. X squared. And then x minus I, x plus I. You can leave this one in factored form because it's extremely long. You could multiply this out, but it's going to be a really long problem. So we're just going to leave it just like this. So this is just written out in factored form. All right, our next problem, here's what we've got. So you've got least possible degree, 0, 7, 1 minus 4i. So then you also have 1 plus 4i, and this one we can multiply out. So technically, we'll say if there's more than 5 zeros, don't multiply it out, okay? Just leave it in factored form. So let's put this out. So you've got x minus 7, then you have x minus 1 minus 4i, and then x minus 1 plus 4i. Let's go ahead and do the i's first since there's only one real factor here. So let's see, this is going to become x minus 1 plus 4i. And this is going to become x minus 1 minus 4i. Okay, so let's go ahead and multiply this out. All right, so we're going to do the x's first. So you've got x times x. It's going to be x squared. X times negative 1, negative 1x. X times negative 4i. It's going to be negative 4xi. All right, then I'm going to do the 1. So I've got negative 1 times x. That's going to be a negative 1x. Negative 1 times negative 1 gives me positive 1. Negative 1 times negative 4i will give me a positive 4i. Okay, then we will do the 4i. So you've got 4i times x. That's going to give us a positive 4xi. 4i times negative 1. That's going to be a negative 4i. And then 4i times negative 4i will be a negative 16i squared. Okay, so now let's combine what we've got here. So you've got x squared by itself. You have a negative 1x and a negative 1x. It's your only x term, so that's a negative 2x. You have a negative 4xi and a positive 4xi. So these are going to cancel each other out. You have, let's see, you've got a positive 4i and a negative 4i. These are going to cancel each other out. You have the positive 1. And you have negative 16i squared. Remember, I squared is negative 1. So this is negative 16 times negative 1, which gives you plus 16. So this is x squared minus 2x plus 17. Okay, then bring down this x minus 7. And let's multiply this out. So we'll do the x's first. So we'll have x times x squared. That's going to give us x cubed. X times negative 2x will give us a negative 2x squared. X times 17, 17x. Okay, then we'll do the negative 7. So negative 7 times x squared, negative 7x squared. Negative 7 times negative 2x will give us a positive 14x. Negative 7 times positive 17 is going to be negative 119. Then let's add these together. We're going to have x cubed. Negative 2 minus 7 will give us negative 9x squared. 17 plus 14 should give us a 31x minus 119. So this should be your answer. We didn't have any other conditions. Let's go ahead and check that, put it in our graphing calculator just to make sure we can see at least the 7 because our other zeros are imaginary. So x cubed minus 9x squared plus 31x minus 119. Okay, so 1, 2, 3, 4, 5, 6, 7. So we can at least see the real zero. So I think we're good to go with the multiplication. All right, and then number 2, we have a third degree polynomial, and then we have a condition at the end of it. So we've got our zeros, 4 and I, which means I also have a negative I. So let's go ahead and set that up. So you've got x minus 4, then you have an x minus I, and then you have an x minus negative I, which gives you x plus I. So let's go ahead and multiply out the x minus I, x plus I first. So we have x times x, x squared, x times I, positive xi, negative I times x, negative xi, negative I times positive I, negative I squared, which is negative 1. So this turns into minus negative 1, so plus 1 there. These two middle terms are going to cancel out. So I have x squared plus 1. Okay, then x minus 4 comes down. We multiply this out. So x times x squared, x cubed. Whoops. There we go. There we go. Okay. X cubed. Then x times x, or sorry, x times 1. Just x. Negative 4 times x squared, negative 4x squared. And negative 4 times positive 1, negative 4. All right, so we have the polynomial function. And that is going to be x cubed minus 4x squared plus x minus 4. Now we're meeting these conditions where p of 1 equals 12, which means I have an a value, okay, your leading coefficient, that might not be 1. So we have to find what that is. So your input is 1, your output is 12, which means this is your output, this becomes 12, and then your input is 1. So all of these x values are going to become 1. So you have 1 cubed minus 4 times 1 squared plus 1 minus 4. So let's see what that gives us. We have, let's see, 1 cubed is 1 minus 4 times 1 squared, so 4 plus 1 minus 4. So this is going to be, let's see, 1 minus 4 plus 1 minus 4. So we get negative 6. All right, so this gives us this problem here. So we solve for a, which means we divide both sides by negative 6. And 12 divided by negative 6 is negative 2. So our a value is negative 2. So then what we're going to go do is we're going to go back to this part of the problem, and we're going to plug a negative 2 in for our a value. And since I'm a little bit out of room, what I'm going to do is I'm just going to erase this, and I'm going to put the -2 in. Okay, then you're going to distribute this. So your polynomial function is going to be -2x cubed plus 8x squared minus 2x, and then plus 8. And then checking that, we should be able to see the 4 and not the i's. Okay, so we should at least just see a +4. So let's see here, -2x cubed plus 8x squared minus 2x plus 8. And there's our 4 right there. Okay, so we see the 4, so we know we are on the right track. We're good to go here. So this is your polynomial function.